Welcome, welcome, one and all. Hello, it is time again for the York Observatory YouTube TeleTube program, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. This is Dr. Elena Hyde, and I am really thrilled to bring you a wonderful presentation by our students today on space exploration. Today, you will be hearing from your hosts, Gagan, Noah, Jean-Luigi, and Sana. And we will be broadcasting these tonight as well as every Wednesday night at 7:30 p.m. local Toronto time. Just FYI, if you would like to email us for any questions or comments, please send us an email at observe@yorku.ca. And of course, you can always follow us on Twitter or Instagram at York Observatory. We will be monitoring the comment area for questions during the broadcast as well as afterwards. So feel free to chime in with any questions you might have. All right, crew, take it away.
Hello, I'm Noah, and along with me today are Sana, John Luigi, and Gagan from York University's Allen I. Carswell Observatory. Today, we'll be discussing a bit about the past, present, and future of space exploration. We hope you enjoy and that you learned something new from this presentation. Space exploration is enormously present in society and has been for decades. From satellites to probes, crewed missions to uncrewed, exploration around our own planet Earth has been heavily focused on and is continued to this day. The first objects ever to be sent into space by humankind were satellites. In fact, in 1957, the very first satellite, Sputnik 1, featured on the top right of the slide, was launched. A few months later, the United States sent up Explorer 1, the predecessor of Explorer 6, which took the image of Earth on the left, and so began the space race. Since then, satellites have had a wide prominence throughout history, all the way to the present day. Many orbit Earth currently, as can be seen in the middle depiction, and have a multitude of purposes. They have been used for research on the Earth, including on oceans, weather, and Earth's atmosphere, for communications, and for astronomy. Currently, the Canadian Space Agency is involved in the CubeSat project, the deployment of a cube that is designed and developed by university students. The purposes of these satellites range from testing various technologies that may be used in future missions, to science, where the satellite can measure and experiment from orbit. The two other recommended uses are commerciality and education. All this from a machine the size of a hand? Impressive. And common, as over 500 CubeSats have been sent into orbit from the International Space Station through ejection by a spring. Well, our life is pretty much indebted to satellites. Without them, society would most definitely not be the same. The Hubble Space Telescope is its own satellite, a very famous telescope which is often considered an observatory in itself, the first telescope that has been launched and exists in space, free of Earth's atmosphere and pollution. It actually took its first image around a month after its launch in 1990 of NGC 3532, a star cluster. It travels 547 kilometers above sea level at 27,300 kilometers per hour in Earth's orbit, using solar panels for energy. Did you know that a reason why its more than 150 terabytes of images are so brilliant is that it can see a wide variety of light from ultraviolet radiation to infrared? Not to mention it has a near impeccable accuracy and can image the universe from over 13 light years away. I also find it really cool that it lacks thrusters. So to turn, it uses wheels that rotate on the principle that all actions and forces have an equal and opposite reaction. The two images on the left are of the Eagle and Butterfly nebulae, as taken by Hubble. And be sure to keep an eye out for the newest space telescope, the James Webb Space Telescope, planned for launch on March 30th, 2021. Many people, at some point of their life, desire to be an astronaut. This career inspiration began with the very first crewed mission in 1961. That year, Vostok 1 launched, and Yuri Gagarin became the first human not only to enter space, but to orbit Earth. Some other notable astronauts that ventured near Earth include Alan Shepard, the first American in space in 1961, John Glenn, in the left image aboard Friendship 7, the first American to orbit the Earth in 1962, and Valentina Tereshkova, the first woman to travel to space in 1963. These early missions, including those of NASA's Mercury and Gemini programs, the latter featured in the center, focused on getting humans to space and orbiting Earth. Then later, engaging in the first few spacewalks as per the right photograph, and rendezvousing and docking with other spacecraft. These experiments and tests set the foundation for the future of spaceflight. After the space race concluded, numerous countries joined forces, leading to the construction of various space stations that orbited and currently orbit Earth, from Salyut 1 to Skylab. However, the more prominent ones are Mir in the left image and the International Space Station, as you can see on the right. Mir was launched in 1986 as an in-orbit observatory, as well as a materials science and environmental laboratory. Throughout its 14 years of existence and 10 years of constant human presence, more than 100 astronauts visited Mir and participated in 40 missions. Mir underwent a large variety of trials and tribulations, such as fires and collisions. However, it successfully deorbited and entered Earth's atmosphere in 2001, as the International Space Station was nearing completion. Amazingly enough, the International Space Station itself has had a constant human presence for nearly 20 years now. Right now, Anatoly Ivanishin, Ivan Wagner, Chris Cassidy, Bob Behnken, and Doug Hurley are in residence 400 kilometers above us. Currently, visits are being made on Soyuz spacecraft. However, this has just recently expanded to private rockets, such as Crew Dragon's launch on SpaceX's Falcon 9. Throughout the International Space Station's 20 years, it has been the subject of a variety of experiments and research opportunities, just as Mir had before it, from technology to biology, space science to human research, and beyond. Canadian experiments are focused on the effects of radiation and microgravity on human health, particularly on heart and bone health. Throughout these space station missions and the eras that encompass their lifetimes, astronauts have broken boundaries and set a myriad of records. Peggy Whitson became the first female commander of the International Space Station in 2008, and Christina Koch and Jessica Meir participated in the first ever all-female spacewalk just last year. In the meantime, the years that oversaw these programs witnessed the growth of the Canadian Space Agency and its contributions. While the Canadarm was present on the space shuttles that were active around the same time, the Canadarm2 and Dexter are currently in use aboard the International Space Station. Space robotics used to fix mechanical issues, assist on spacewalks, and capture arriving vehicles, to name a few purposes. Also, Chris Hadfield was the first and only Canadian astronaut to have flown on Mir, while many other astronauts have visited the International Space Station. Robert Thirsk, Chris Hadfield, and David Saint-Jacques are 3 of the 7 Canadian astronauts to have visited the International Space Station. As I mentioned, the Space Shuttle era overlapped many other programs in its 1981 to 2011 lifetime and consisted of reusable spacecraft, as illustrated on the top right, the very first of its kind, namely Atlantis, Columbia, Challenger, Discovery, Endeavour, and Enterprise, the last of which never actually exited Earth's atmosphere. Although both Columbia and Challenger resulted in disasters, during re-entry of its 28th flight in 2003 and during liftoff of its 10th mission in 1986, respectively, the shuttle missions overall proved rather successful. While Sally Ride became the first female American astronaut, in space in 1983, featured in the bottom right image, Marc Garneau became the first Canadian in space in 1984, both on the shuttle Challenger. A fun fact about Space Shuttle Endeavour is that it's spelled the British way, not the American way. It has a U in it. This is due to the fact that it was named by children after a British ship of the same name, consisting of the U spelling. One of the studies done aboard a space shuttle was Neuralab, an American, Canadian, European, and Japanese effort, including the independent space agencies of France and Germany. It was actually conducted by one of Canada's very own astronauts, Dave Williams, studying the nervous system in microgravity. In fact, an enormous 26 experiments on the neurological aspects of balance, senses, navigation, growth and development, circulation, and sleep were conducted throughout 16 days in space. Now, let's move on to another key location of exploration, as explained to you by Sana.
Thank you, Noah. Now that you've heard about near-Earth exploration, let's take a step 400,000 kilometers away to the moon. The early days of lunar exploration were dominated by the space race, which had a goal to achieve safe manned landings on the moon. Because of this, only the United States and the Soviet Union launched missions to the moon at the time. Physical exploration of the moon began in 1958 with the Soviets' Luna program. The Luna program holds the record for many firsts in lunar exploration, including the first man-made impactor, or hard landing, with the Luna 2 spacecraft, the first man-made object to safely land on the moon, or a soft landing, with the Luna 9 spacecraft, and the first lunar orbiter with the Luna 10 spacecraft. These were also the first man-made objects to ever achieve these milestones on any object other than the Earth. The lunar probe provided scientists with many important measurements about the magnetic field, radiation, and even volcanic activity on the moon. They also provided the first up-close images of the moon, including lunar farside. NASA ran 5 unmanned programs to explore the moon, all with the goals to learn more about it, and all these missions were geared towards preparing for manned landings. Here are some of the most important results from these missions. The Surveyor spacecrafts were the first NASA probes to achieve soft landings on the moon and did the first ever surface samples and soil analysis, providing scientists with the ability to study the moon's composition and history. The Surveyor probes also proved that astronauts would be able to walk on the moon and achieved the first liftoff from the lunar surface. The Lunar Orbiter program consisted of probes that orbited the moon, during which they took many measurements, including mapping the entire near side of the moon and 95% of the far side. These missions proved critical for picking out landing sites for the manned Apollo missions, as well as mapped the moon's gravitational field and discovered a crustal fault on the far side. Manned missions to the moon began with NASA's Apollo program in the 1960s. The first crewed mission to launch was Apollo 7. Apollo missions 7 and 9 were Earth orbiting and tested various parts of the spacecraft, and Apollo missions 8 and 10 went into orbit around the moon and performed further tests of the spacecraft, with Apollo 10 serving as a dress rehearsal for the first crewed landing. Astronauts aboard Apollo 8 were the first humans to ever orbit the moon and the first ones to ever see the far side of the moon. The Apollo 11 mission was the first crewed landing on the moon and landed on July 20th, 1969 in the Sea of Tranquility. The mission consisted of 3 crew members, Neil Armstrong, Michael Collins, and Buzz Aldrin. About 6.5 hours after landing on the moon, Neil Armstrong and Buzz Aldrin became the first humans to walk on the moon, while Michael Collins stayed in orbit around it. There were 6 Apollo missions after Apollo 11, which were all successful except for Apollo 13, which is regarded as a successful failure. Apollo 13 never landed on the moon due to an onboard explosion that crippled part of the spacecraft. Instead, they safely completed a round trip to the moon and back, and even broke the record for the furthest distance any human has traveled from the Earth. All successful missions after Apollo 11 further explored the lunar surface, with Apollo 15, 16, and 17 making use of lunar roving vehicles so they could travel further away from their landing site. Many different experiments were deployed during the Apollo missions, and nearly 400 kilograms of soil was returned to the Earth overall. This led to numerous new discoveries about the moon. One important new discovery is its origin. Sample analysis shows that the moon and Earth have very similar compositions, which leads to the current theory on its formation, the giant impact hypothesis. This states that in the early history of the solar system, a Mars-sized object would have collided with the Earth, sweeping away material that eventually coalesced to form the moon. Other analysis showed that while the moon is currently inactive, it used to have an active core with volcanic activity and magma oceans, which further leads to discoveries about its evolution and structure. The final Apollo mission was Apollo 17 and ended on December 13, 1972, marking the last time that humans went to the moon. While humans have not returned to the moon in over 50 years, lunar exploration has continued, and currently 7 countries have sent probes to the moon. Here are just a few of those missions. The lunar program continued until 1976 and expanded its operations to include orbiters, rovers, and even deploying robotic probes on the lunar surface, which had never been done before. In 1990, Japan's space agency, JAXA, launched the Titan spacecraft that completed a flyby of the moon and released an orbiter. In doing so, Japan became the 3rd country to ever send a probe to the moon. More recently, in 2008, India's space agency, the ISRO, had the Chandrayaan-1 mission, which contained an orbiter and a lunar impactor. This mission was critical in the discovery of water on the moon. In 2007, China's space agency, the CNSA, began the Chang'e program, which has currently sent 4 probes to the moon, 2 of which included rovers. Among other things, these missions have created a 3D map of the moon, and in 2019, the Chang'e 4 spacecraft became the first man-made object to achieve a soft landing on the far side of the moon. Since the Apollo program, NASA has also sent multiple missions to the moon. Two important missions are the Lunar Reconnaissance Orbiter, the LRO, and the Lunar Crater Observation and Sensing Satellite, or LCROSS. LCROSS consisted of an orbiter and a lunar impactor, and the LRO is an orbiter. Both of these missions studied resources on the moon. They determined that the moon has a water cycle, is chemically active, and that many resources, including water, are found in the shadows of craters. While many space agencies have plans for unmanned missions to the moon, including further Chandrayaan and Chang'e missions, as well as the continuation of the LRO, there are also plans for humans to return to the moon, with the Artemis and Lunar Orbital Platform Gateway programs. The Artemis program is run by NASA and plans to bring humans, including the first woman, to the moon by 2024 and to establish a strong human presence at the moon by 2028. Platform Gateway is planned to be the lunar space station where Artemis astronauts will live while at the moon. This project is an international collaboration between NASA, JAXA, the European Space Agency, Russia's space agency Roscosmos, and the Canadian Space Agency, who will be contributing the Canadarm3. Platform Gateway and Artemis will also help to put astronauts on Mars, which John Luigi will tell you more about next.
All right, in my opinion, for the last 2 decades, when you would hear anything about space exploration, your mind would immediately take you to Mars. If there was or is life on the Martian surface, and if humans will ever conquer and land successfully on the planet to create a new home. Let's go into a journey through milestones that humans achieve and will in the future on Mars exploration. Despite the USSR project enrolled Mars 3 in 1971 was the very first successful lander on the Martian surface, being functional for about 14.5 seconds. The Viking project consisted of 2 spacecraft, Viking 1 and 2, not only landed safely, but collected data for almost 10 years. Both rovers were powered by radioisotope thermoelectric generators, electricity generated from heat given by natural decay plutonium. Both orbiters landers were launched in Mars in 1975 and landed safely. The prime reason for this mission was to finally detect any type of biolife, form, or source and observe the meteorologic, seismic, and magnetic properties of Mars. Results showed unexpected and enigmatic chemical activity in the Martian soil, but provided no clear evidence for the presence of living microorganisms in soil near the landing sites. According to scientists, Mars is a self-sterilizing. They believe the combination of solar ultraviolet radiation that saturates the surface, the extreme dryness of the soil, and the oxidizing nature of the soil chemistry prevent the formation of living organisms in the Martian soil. Both Viking Lander 1 and 2 made their final transmission to Earth in 1982 and 1980, respectively. But the next successful orbiter after Viking was the Mars Global Surveyor, launched in November 1996, meant to study and map the entire Martian surface, atmosphere, and interior. With its camera, the Mars Orbital Camera, in short MOC, the spacecraft observed repeatable weather patterns. Once created maps, it showed a record of changing meteorological conditions on Mars. Some dust storms would form in the same locations around the same time every year, every other week, or dust devils will form around the first few days of spring till mid-Martian autumn. Additionally, with a high-resolution panoply of images, it documented gullies and debris flows, suggesting that occasional sources of liquid water, similar to an aquifer, were once present at or near the surface of the planet. Also, magnetometers readings have shown that the planet does not have a global magnetic field, but has localized magnetic fields in a particular areas of the crust. The spacecraft laser allowed to create a 3D view of Mars' North Polar ice cap and show a decreased amount of carbon dioxide in the South Polar cap. Overall, Mars Global Surveyor has shown that Mars is a dynamic planet with a complex history of seasonal and long-term change recorded on the planet's surface, like in the center image where a unique type of bedrock layers are shown in Valles Marineris, arguing that there is a deeper layers or rubble under all the Martian surface. The spacecraft stopped sending data after 10 years in 2006. Despite the fact that in the past decades, no clear evidence of biomicroorganisms on Mars were shown and further studies were required to determine water sources underground, the idea of having green aliens living next door was close to impossible. But chances that the planets could host life millions and millions of years ago was still a possibility. The aspect take us to recent and current missions, in particular Curiosity project by NASA. The Curiosity is the largest and most capable rover ever sent to Mars and managed to land successfully on the planet on August 2012. Its job is to study and understand the rock and soil composition, as well as atmosphere of the planet to determine if the current environment could have possibly been habitable eons ago. During the 2,820 days of the rover experience on Mars, Curiosity has made tons of discoveries using several instruments such as drills, laser, imaging instruments, taking about 469,000 images back to Earth. Some of these evidences are images of sand dunes with wind-sculpted ripples, which do also exist on Earth. However, bigger ripples of about 10 feet in size, like in the image taken at the Nabit Dune in the Banyol Dune field, are a distinct type on Mars. Furthermore, the bottom image in the higher regions of Mount Sharp, it shows a different layer of minerals such as hematite, clay, or sulfate. The changing mineralogy in these layers on Mount Sharp suggests that a changing environment in early Mars, though all involve exposure to water billions of years ago. Despite the tons of mission, Mars will still have the attention of scientists and astronomers for a little while. NASA is meant to launch soon a new mission to Mars, Mars 2020, which includes the rover Perseverance. This rover will be so unique compared to the previous one as it will be the first rover with an helicopter drone called Ingenuity, which will help scout interesting objects on Mars. It will investigate an astrobiologically relevant ancient environment on Mars and investigate its surface geological process and history, including the assessment of its past habitability, the possibility of past life on Mars, and the potential for preservation of biosignatures within accessible geological materials. While exploring an habitable area on the Martian surface, the rover will collect and package as many as about 31 samples of rock cores and surface soil for a later mission to bring back for definitive analysis on Earth. Aside NASA's mission, another very relevant one from other agencies is the one from the Indian Space Research Organization and first mission to Mars, Mars Orbiter Mission, which studies the surface and atmosphere of the planet from orbit, becoming the fourth agency to successfully launch a spacecraft to Mars. They're actually planning to send a second orbiter in 2024 called Mars Orbiter Mission 2. The orbiter will use aerobraking to lower its initial apoapsis and enter into an orbit more suitable for observations. And lastly, concluding this section about Mars, we don't have to forget about us. NASA's human lunar exploration plans under the Artemis program call for sending the first woman and the next man to the surface of the moon by 2024, and will establish sustainable exploration by the end of the decade. This agency will use what they learn on the moon to prepare for humanity's next giant leap, which will be sending astronauts to Mars. Working with US companies and international partners, NASA will push the boundaries of human exploration forward to the moon and to Mars. It all starts with US companies delivering scientific instruments and technology demonstration to lunar surface, followed by spaceship called the Getaway, and in orbit around the moon that will support human and scientific missions, and human landers that will take astronauts to the surface of the moon. The moon is such a treasure chest of science that holds many fascinating mysteries to explore, many that will advance our understanding of our home, planet, and solar system, as well as the cosmos beyond. NASA wants to use the moon's unique perspective as a science platform to look back at Earth, observe the sun, and view the vast universe. The discovery of water on the moon and possible deposits of rare earth metals also hold promise for both scientific and human exploration. Because of this, living on the gateway for months at a time also will allow researchers to understand how the human body responds in a true deep space environment before committing to the years-long journey to Mars.
Thank you, Gianluigi. After reaching the solar system's terrestrial planets, the next big endeavor for space exploration was the outer solar system. In 1972, no space probe had ever crossed the asteroid belt between Mars and Jupiter, but that was about to change. Let's take a look at how we've explored the outer planets over the last few decades. First up, we have the outer planetary Pioneer missions, Pioneer 10 and 11. The Pioneer missions were a series of space probes launched to gather information about the moon and other planets in our solar system. True to their names, Pioneer 10 and 11 were the first probes to encounter Jupiter and Saturn, respectively. Pioneer 10 was launched in March 1972 and flew by Jupiter in 1974 at a distance of less than 130,000 kilometers from the surface of its atmosphere. The primary focus of Pioneer 10 was to study Jupiter and its surrounding environment. Over the course of the mission, the probe mapped out Jupiter's magnetic field, its radiation belts, and also returned the first close-up images of Jupiter. Unfortunately, Pioneer 10 encountered some radiation damage, which diminished the quality of data able to be collected and returned. The image on the left is one of the images of Jupiter taken by Pioneer 10. After passing Jupiter, the probe went on to study solar wind and cosmic rays in the outer solar system and continued to return data until 1997. The mission was officially ended in January 2003 when the final signal from the probe was received. In April 1973, while Pioneer 10 was still on its way to Jupiter, NASA launched Pioneer 11 to study the asteroid belt, Jupiter, Saturn, and the outer solar system environment, with a focus on Saturn and its surroundings since no craft had ever visited Saturn before. Pioneer 11 reached Jupiter in 1974 and Saturn in 1979, returning images of both planets. The images taken of Saturn were the first close-up images of Saturn ever taken, as shown on the bottom left. In addition to studying Saturn's outer atmosphere and magnetosphere, Pioneer 11 also discovered two previously undetected moons orbiting Saturn and determined Titan to be too cold for life. The middle image is Pioneer 11 images of Jupiter, and the image on the right is the image of Pioneer in construction. Another set of early missions were the Voyager missions. The Voyager space program was a program consisting of two twin space probes to study the planets Jupiter and Saturn. The mission was extended after early success to include encounters with Uranus, Neptune, and the interstellar medium, which is the area of space beyond the reach of our solar system. Voyager 1 was launched in September 1977, and its primary mission included flybys of Jupiter and Saturn, as well as a close flyby with Saturn's moon Titan, transmitting several close-ups of both planets and their moons. One of the most important observations made by the Voyager 1 probe was that of volcanic activity on Jupiter's moon Io. This was the first time present volcanic activity had been observed anywhere other than Earth and can be seen here in the bottom middle of the slide. Voyager 2 was launched 16 days before Voyager 1 and visited all four giant planets, Jupiter, Saturn, Uranus, and Neptune. To date, Voyager 2 is the only probe to ever have visited Uranus or Neptune and delivered the first close-up images of these planets and their satellites. It discovered 11 new moons around Uranus, as well as 6 new moons and a ring system around Neptune. Both Voyager probes crossed into the interstellar medium and continue to transmit useful data back to Earth as part of the Voyager interstellar mission. Voyager 1, despite launching after Voyager 2, overtook it prior to reaching Jupiter and is the furthest man-made object in space at a distance of 22.2 billion kilometers, still traveling at a speed of 17 kilometers per second. Now, moving on to some of the more recent outer solar system missions, starting with Cassini-Huygens. The Cassini mission by NASA, ESA, and ASI was a combination probe and lander mission to study Saturn and its moons. It was launched in 1997 and reached Saturn and entered orbit in 2004. The Cassini probe continued to orbit Saturn while the Huygens lander deployed to Titan during a flyby, where it successfully landed and transmitted images and data about surface features and atmospheric conditions. The Huygens mission marked the first time landing had been accomplished in the outer solar system or on a moon other than Earth's moon. The image on the left is an image Huygens took from the surface of Titan. While Cassini orbited Saturn for the next 13 years, it continued to study and image the atmosphere, rings, and moons. Data from the Cassini missions allowed us to determine Saturn's rotational period, map Titan's topography, discover 7 new moons, and also learn more about Saturn's atmosphere dynamics and ring system. Another incredible discovery from Cassini was the radar image evidence of hydrocarbon lakes on Titan that were comparable in size to the Great Lakes in Ontario. These were the largest liquid lakes found anywhere in the solar system at the time. Probably the coolest thing, in my opinion at least, about the Cassini mission was the way the Cassini team decided to end it. To avoid biological contamination of Saturn's moons and to acquire final data from as closest Saturn's atmosphere as possible, Cassini dove towards Saturn from orbit, sending data and images of the atmosphere and rings as long as possible. The mission ended with Cassini's destruction upon entering the atmosphere in September 15, 2017. New Horizons was a mission launched in January 2006 with a primary objective of completing a Pluto flyby. At the time that New Horizons was planned and launched, Pluto was still considered the 9th planet in our solar system. Pluto was actually demoted in status to a dwarf planet only a few months after the probe's launch in August 2006. On its way to Pluto, the probe imaged and collected data from Jupiter and the Jovian moons during a flyby as a systems test. 5 years ago yesterday, on July 14, 2015, New Horizons became the first craft to ever perform a Pluto flyby and transmitted a famously high-resolution photo of its surface and Pluto's heart as seen on the left. New Horizons successfully mapped Pluto and Charon's geographies, as well as encountered Kuiper Belt object Arrokoth on its way out of the solar system. Along with Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, New Horizons is the 5th craft to be able to leave the solar system and is expected to do so in 2038. Finally, the Juno mission is a currently ongoing Jupiter orbiting mission, launched on August 5, 2011. It is the 2nd spacecraft to ever orbit Jupiter, the first being the Galileo craft. Juno's primary mission is to study Jupiter's composition, atmosphere, and magnetosphere. Juno will also look to determine properties of Jupiter's core as well as its water content, which will be useful in learning about Jupiter's formation. The name for the mission comes from Roman mythology, where the goddess Juno is the wife of god Jupiter. Juno is pretty much going to check up on her husband Jupiter just to see what he's up to. Over the years, Juno has managed to take some extremely detailed images of Jupiter, which can be seen here. Juno is also the first outer solar system probe to be powered by solar panels, and the 3 arrays also mechanically stabilize the craft as well as power it. Juno was the most recent mission to the outer planets of our solar system, but there are several future missions currently in planning and development stages. Most of these missions will be focusing on Jupiter and its moons, with the exception of the Dragonfly mission, which is headed to Saturn to deploy a lander on Titan. With space exploration gaining momentum, we hope to have more to update you all about soon, but until then, we can appreciate all the missions that have brought us to where we are today. This concludes our presentation for this evening. You've been listening to the Alan I. Carswell Observatory's weekly TeleTube broadcast, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Noah, Senna, Jean-Luigi, and myself, Guggen. Make sure to leave any comments in the comment section of the video below. You can always connect with us on Twitter or Instagram with the handle @York Observatory, and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good night.